Let's understand Introduction to Probability in this video. Have you ever wondered how likely it is to rain, or to win a lucky draw, or to get heads when you flip a coin? Probability helps us answer these everyday questions in a simple way. Think of probability as a kind of measurement, like length or weight, but for chance. It tells us how confident we are that an event will happen. A random event is one where we know the possible outcomes, but we do not know which will come up. For example, a coin can land heads or tails, but we cannot be sure before we toss it. Sometimes we guess based on what we see, and that is called subjective probability. Like saying, the sky looks dark, so it might rain. But we can also measure chance more carefully using two main methods: experiments and theory. Experimental probability uses real tests or observations and is also called relative frequency. The formula is simple: number of times the event happened divided by the total number of trials. For example, if a coin is tossed 40 times and heads shows 18 times, the experimental probability is 18 divided by 40, which is 0.45 or 45%. If a die is rolled 60 times and 6 appears 10 times, the probability of getting 6 is 10 divided by 60, which equals 1 divided by 6, about 0.167 or 16.7%. Theoretical probability is what we expect in a perfectly fair situation, without doing experiments. We use this when all outcomes are equally likely, with the formula number of favorable outcomes divided by number of possible outcomes. For a fair six-sided die, the chance of getting an even number is 3 favorable outcomes divided by 6 possible outcomes, which is 1 divided by 2 or 0.5. If you pick a letter from the word maths, the chance of picking M is 1 divided by 5 or 0.2. Probability is measured on a scale from 0 to 1, where 0 means impossible and 1 means certain. If probability is 0.5, that means both outcomes are equally likely, like heads or tails on a fair coin. Values less than 0.5 mean the event is less likely, and values greater than 0.5 mean the event is more likely. Randomness means you know all possible outcomes, but you cannot predict which one will happen, and each trial can be repeated under the same conditions. A random experiment is something you can repeat, such as tossing a coin, rolling a die, or drawing a card. The sample space is the full list of all possible outcomes, and the sample size is the number of items in that list. For example, the sample space for a single coin toss is heads and tails, and for a die roll, it is 1 to 6. An event is any single result or group of results from the sample space, like getting an odd number or drawing a face card. Tree diagrams help us see all outcomes in multi-step experiments by drawing branches for each step. If you roll a die twice, the tree shows 36 outcomes, and the chance of getting 3 then 3 is 1 divided by 36. If you toss a coin and roll a die, there are 12 outcomes, and the chance of getting heads and then 4 is 1 divided by 12. The law of large numbers tells us that as we do more trials, the experimental probability usually gets closer to the theoretical probability. Remember the gambler's fallacy. Past random events do not change future independent events. A coin has no memory, and each toss is still 1 divided by 2 for heads. A fair or unbiased coin means both outcomes are equally likely, because the coin is symmetrical and not weighted. In statistics, we use samples to learn about a whole population. So sampling must be fair and represent the whole group. By collecting data from a sample, we can estimate probabilities for larger groups, like how many students might like a sport or subject. A quick note: the game Snakes and Ladders began in ancient India as Gnan Chopad to teach good and bad behavior. So probability ideas have roots in our culture too. So, what do we learn from this? We learn that probability measures chance, can be found by experiment or theory, uses sample spaces and events, and helps us make sensible guesses. Let us quickly remember, probability is between 0 and 1. Experimental probability is times occurred divided by trials, and theoretical is favorable over possible outcomes. So today we learned key ideas, simple formulas, and useful examples to see probability around us. Keep exploring with small experiments at home, like tossing coins or rolling dice, and watch how chances play out. Happy learning! And if you want more clear lessons and practice, explore similar topics on EduRev at your own pace and without pressure.